Hi everyone. In this video, we are going to talk about how to find the least common denominator of rational expressions. Why do we need to find this least common denominator? Well, whenever we add or subtract fractions, whether or not they just have numbers or numbers and variables in the bottom, we need to get common denominators. But for any two given fractions, there are lots of common denominators we could have. And we want to find the easiest, which is the smallest or least common denominator of rational expressions. In this video, we are only going to talk about how to find the LCD. In future videos, we are going to talk about how to actually add and subtract these rational expressions, which is going to use the LCD. The first example we're going to go through, when you see it, you're going to freak out and say, oh, this looks really, really hard. But trust me, this first example looks really hard, but it's not too bad. Actually, it's easier than some of the examples we're going to do later in this video. And this first example, even though it looks hard, is great for teaching purposes. So let's go do this first example. It says, find the least common denominator, or LCD, of the rational expressions with these two giant fractions. First of all, since we're finding the least common denominator, we can ignore the numerators or the tops of the fractions. They're not going to have anything to do with anything in your answer. And when you find the LCD, you want to think about the word more. So looking at these two denominators, this first denominator has a 2. Does the second denominator have a 2 as a constant? No, it has a 2 as an exponent, but that's not a constant. Which fraction has more plain 2's? Well, this first fraction does, so we need a 2 as part of your LCD. Looking at your second fraction, we have a 7 as your constant. Is there a plain 7 over here in this first fraction? No. We have a couple 7's as exponents, but they're not constants. They're not plain 7's. So which fraction has more 7's? Well, the second fraction does, so we need a 7 in your LCD as well, and we're going to multiply that by the 2 that we already have. Now let's keep going and think about this word more. Which fraction has more plain x's? Well, this first one does. We have an x to the third. That's the more, so that's what we need in your LCD. Which fraction has more y's? Y to the 7th or y to the 8th? Well, this one has 8 y's multiplied, y to the 8th. So we need whichever one has more in your LCD. We need y to the 8th as part of your LCD. Now go on to your binomials. We have an x minus 8 and we have an x minus 8 to the third. Which one is more? Well, x minus 8 to the third is more, so we need x minus 8 to the third in your LCD. For the x plus 4's, which one has more? Well, they both have a 2 as an exponent, and they have the same amount of x plus 4's, so we just keep the same amount, x plus 4 to the second. And for the x minus 10's, the first fraction has more x minus 10's, so we need an x minus 10 to the 7th as part of your LCD. Then just take 2 times 7. 2 times 7 is going to be 14. So there is your LCD. Not too bad. Let's go on and do another few examples. Okay, so we have two fractions and it asks you to find the LCD, or least common denominator. Ignore the numerators. For the first fraction, we have an x minus 7 as the denominator. Remember, x minus 7 is a factor that goes all by itself. It's not an x and a minus 7. It's a thing unto itself. It's an x minus 7. So the first fraction has an x minus 7. It has one of them. the second fraction does not have any of x minus 7s. Which one has more x minus 7s? Well, the first one has more x minus 7s, so we need that more as your LCD. Which one has more x plus 2s? Well, the second fraction has more x plus 2s, so we also need an x plus 2 multiplied to the x minus 7 as your LCD. Just leave it in the factored form, don't FOIL those out, and there you're done. For the next two fractions, which one has more y's? Well, the first one has more y's, so we need y to the 9th in your LCD. Which one has more z's? Well, they have the same amount of z's, so we just need a z as part of your LCD. And for the last set of two fractions, which one has more x's? Well, the first one has more x's, so we need an x to the 2nd as part of your LCD. This one has an x minus 7. This one does not. Which one has more x minus 7s? Well, the first one does, so we need a single x minus 7 factor as part of your LCD. And which one has more x plus 3s? The second fraction does, so we need a single factor of x plus 3 as part of your LCD. Not too bad. Okay, we've got a few more examples here. Here it says, find the LCD of these rational expressions. Say, oh boy, now we've got numbers in the bottom. We've got a 12x in the bottom of the first fraction and an 81 in the bottom of the second fraction. If the numbers are small enough, what you could do is say, what is the smallest or least number, the smallest number that both 12 and 81 go into? Not what goes into both of them, but what do they both go into? It's going to be bigger than both of them. I don't know about you, but I don't know what number both 12 and 81 is going to go into. So let's start by making a factor tree for both of those numbers. 12 is a 2 times 6. 6 is a 2 times 3. Cross off the numbers once you break them down. 81 is a 9 times 9, and both 9s are 3 times 3. So when you're finding the LCD, you think about the word more. Looking at these two factor trees, which one has more 2's? Well, the first one has more 2's, so we need 2 2's as part of your LCD. Which tree has more 3's? Well, the second tree has many more 3's, it has 4 3's, so we need 3 times 3 times 3 times 3, or 3 to the 4th as part of your LCD. And then, which fraction has more x's? Well, that first fraction has more x's, so we need a single x as part of your LCD. So then, take 2 times 2 times 3 to the 4th. You can use a calculator. I think that's going to end up being 324x as your LCD. Quick double check my math there. 324. Okay, we've got one more type of example on the next slide. Let's find the LCD of these rational expressions. You say, oh boy, these don't look the same. They're not factored. So the first thing we have to do is factor first. You can ignore the numerators when you are finding the least common denominator. For the first fraction's denominator, you want to factor the trinomial by finding two numbers that multiply to -4 and which add up to the number in the middle, -3. Those numbers are going to be a -4 and a +1. Since the x squared has a 1 in front of it, we can go straight to your binomials. They're both going to start with an x, and that denominator factors to be x minus 4 times x plus 1. For the second fraction, the first step in factoring is to find the GCF. Don't get the GCF and the LCD confused. GCF is the greatest common factor. The greatest common factor of 2x to the third and 32x is 2x. Factor out a 2x and you're left with x squared minus 16. But don't stop there, because x squared minus 16 is a difference of squares, which factors to be x minus 4 times x plus 4. So all of that was review. Now let's actually find the LCD. Notice the first fraction has 1 x minus 4. Second fraction has 1 x minus 4. We need an x minus 4 as part of your LCD. First fraction has an x plus 1. Second fraction doesn't, which has more x plus 1s. Well, the first fraction does, so we need an x plus 1 as part of your LCD. Second fraction has an x plus 4. First fraction doesn't. Which one has more? We need an x plus 4 as part of your LCD. And what are we missing? Well, the second fraction has a 2x in front. First fraction doesn't have any monomial as a factor. Which one has more? We need a 2x as part of your LCD. And the last example, we've got 3 fractions. Notice the first already has a factored denominator. Second denominator is already factored. Third denominator is not factored. Factor out a GCF of x, and you're left with x times x plus 2. Now, the LCD is going to be, well, look at the numbers first, a 6 and a 4. You could make factor trees, or you could just think, what is the smallest number that both 6 and 4 go into? Well, 2 goes into both of them, but that's the GCF, that's not the LCD. The LCD is the smallest number that both 6 and 4 go into. Both 6 and 4 go into 12. 6 goes into 12 twice, 4 goes into 12 3 times. 12 is the smallest number that both 6 and 4 go into. So now, looking at the 3 fractions, which one has more plain x's in the bottom? Well, the second one and the third both have a single plain x. We need a single plain x in the LCD. Then look at the x plus 2's. Which one has more x plus 2's? Well, they have the same. So we need an x plus 2 as part of your LCD. And that's all I have for this video. Thanks for watching. In the next video, we're going to talk about how to actually add and subtract fractions by getting the LCD. Have a good day. Thank you. Bye.